Hi everyone, today Michael will answer a few questions based on a few topics, which is metric, quadrats, and vector. And my name is Nur Asma Zabetu Muhammad Isa, and I will answer question 1, which is metric topic. And for question 1a, the question needs the form of metric equation, and the answer is like this: 12, 9, 8, 7, and x, y equal to 288 and 204. For question B, we will use inverse and multiplication to solve this system of linear equation, where we will use AX equal to B. A is 12, 9, 8, and 7. X is unknown x and y. B is 288 and 204. To find x and y, we have to find the inverse, where inverse is 1 over d times 7, negative 9, negative 8, and 12. But we have to get the determinant first from metric A, where 12 multiplied with 7 minus 9 multiplied with 8, the answer is 12. So the inverse A is 1 over 12 times 7, negative 9, negative 8, and 12. Then, to find x and y, we have to multiply inverse A with B. Like we can see here, the solution is 1 over 12 times 7, negative 9, negative 8, and 12 times 288 and 204. And from this solution, we get the answer 1 over 12 times 180 and 144. And for final answer, we get is 1 over 12 multiplied with 180, we get 15. And 1 over 12 multiplied with 144, we get 12. And the answer for x is 15 and y is 12.
This is question 2. I will show how to use Cramer's rule to solve 3 by 3 system linear equation. First thing is we must make a coefficient of d. To make coefficient of d, we just write back the number that before the equal symbol. So we got 1, negative 1, 2, 4, 1, 1, 5, negative 1, and 8. Now we got the value of d, so we can find the determinant of d. To find the determinant of d, we just write back the first number in the first row. So we got 1, and then we ignore the first row and the first column. So we got 1, 1, negative 1, and 8. Now we subtract it with the second number in the first row, which is negative 1. Subtract negative 1, and then now we ignore the first row and the second column. We got 4, 1, 5, and 8. Now we plus it with the third number in the first row, which is 2, so we got and we ignore the first row in the last column, so we got 4, 1, 5, and negative 5. Then we multiply it, so we got 80. So now we can find the determinants of x. But we must make the coefficient of x first. To make coefficient matrix of x, we just need to replace the column of x, which is column first, with the number after the equal sign of our question. So we got negative 1, and 2. Second row we got 30, 1, 1, and the last row we got 5, negative 1, and 8. Now we can find its determinant by multiplying it. So after we multiply it, we got 54. Now we can find determinant of y. First, like we did before, we must make coefficients of y. So we will replace the column of y, which is in the second column, with the number after the equal sign. So we will got 1, negative 1, 2, 4, 31, and the last row we got 5, 5, 8. And we multiplied it like before, and we got the answer for determinant y is 36. Now last is we find the determinant of z. First we make the coefficient matrix of z. We will replace the column of z, which is the last column, with the number after the equal sign. So we got 1, negative 1, negative 1, 4, 130, 5, negative 1, and last is 5. And then we multiply it, and don't forget to write the first number of the first row, so it is 1, and then we ignore the first row and the first column. We got 1, 30, negative 1, and 5, and we subtract it with negative 1, and then we ignore the first row and the second column, so we got 4, 30, 5, 5, and then we plus it with negative 1. We ignore the first row and the last column, so we got 4, 1, 5, negative 1, and we multiply it, we got negative 36 for determinant of z. Now we can find the value of x, y, and z. X is equal to determinant x over d, so it is 54 over 18, so we got 3. So for y is equal to determinant y per d, so we got 36 over 18, it is 2. And last is z is equal to determinant z over d, so we got negative 36 over 18, so the answer is negative 2.
Question 3. Draw the WXYZ trapezium. So this is how the shape of trapezium. The WX line represent the vector s, and W to Z line represent as vector t. Question B. Write vector zy in terms of s. Based on the information given, the ratio of vectors zy and ws is equal to 3:2. Ws9 we know as vector s. So, we can find vector zy by the ratio and vector of ws9. And vector zy is equal to 3/2s. Okay, we solve by comparison to ratio. We know the ratio is 3/2. So, if ws9, which is the ratio is 2, is equal to s, it must be divided by 2s, while zy line, which is the ratio is 3, also need to divide it with 2s. So, the final answer is 3/2s. Question C. Work out vector xy in terms of s and t. Give your answer in its simplest form. Vector ws is equal to vector wz plus vector zy, and the answer is t plus 3/2s. We can find vector xy by vector wy minus vector ws. So, it is equal to 3 plus 3/2s minus s, and the answer is t plus 1/2s. So, the conclusion is matrices are like organized table of numbers helpful for solving lots of equations at once. Cramer's rule is like a shortcut for solving system of equations where you can find each variable's value using fraction made from the number in the equation. Last but not least, vectors are like arrows pointing in space, useful for describing things like direction and movement. These three concepts are super important in math, helping us solve many problems.
This time I want you, like